A carabiner weighs less than 2 ounces. But to emergency responders and other climbers, it's the difference between life and death. These little clips link together the ropes and safety harnesses that climbers connect to anchor points on their climbs. But can such a lightweight clip hold the full weight of a climber? To make the carabiners both as strong and as lightweight as possible, they're made from long rods of the same material used to make the wings on commercial jets. It's a mix, or alloy, of 2 metals, aluminum and zinc. Together, they're lighter and stronger than any single metal on its own. The aluminum is naturally lightweight and pliable, while the zinc adds the strength. Once the carabiners are formed, this alloy can be heat treated to make it one of the strongest kinds of aluminum on Earth. For now, the untreated aluminum is still soft and pliable. So the rods can be easily chopped down into 10-inch pieces and then wrapped around a die or mold that bends the aluminum into the curved shape of a carabiner. The D-shaped bend keeps the carabiner strong because it concentrates all of the weight on the straight side or spine while keeping the weight off the weaker curved side where the gate of the carabiner will open and close. Once the aluminum is bent, the curved pieces travel through an oven that heats them to 800 degrees. This isn't to heat treat them and make them stronger. It's just to soften them up a bit so the aluminum can be stamped into the final form of the carabiner. When the aluminum reaches just the right consistency, a pair of robotic pliers plucks the hot pieces out of the oven and places them in a powerful press that uses a hydraulic die to stamp ridges and gate attachments into the aluminum. It takes 500 pounds of force to press out the carabiners. The incredible pressure also squishes the excess aluminum out of the die, which makes the carabiners lighter. But it leaves a messy edge. So once the aluminum is cool, a trim press cuts away the extra to clean up the edges. Now that the carabiners are fully formed, the aluminum can finally be heat treated in a furnace to activate its super strength. Huge bins holding 5,000 carabiners each are hoisted up into the furnace where the carabiners bake at 870 degrees for 3 full hours. The heat evens out the mix of aluminum and zinc molecules in the alloy and bonds them together to make the alloy even stronger. When the 3 hours are up, the baskets full of carabiners drop out of the furnace and into a vat of cold water to lock in the final molecular structure. But all that strength is no good to a climber unless the carabiners are completely smooth. Because if there's one sharp edge, it could sever the rope. So the carabiners get a good shaking inside a machine called a vibratory that slowly tumbles them in a bath of wet soapy stones to smooth out the sharp edges and burrs. As the carabiners spill out of the vibratory, they're collected up and sent through a polisher that uses soapy water and metal beads to polish the aluminum. Finally, they tumble in a bin of ground corn cobs that polishes them to a pristine shine. Then after a quick paint job, it's time to add the moving parts. A worker drills a hole in one end of the carabiner so the gate, which opens and closes, can attach. A steel pivot rivet holds the gate permanently in place. But before a climber's life is trusted to the carabiners, samples from every batch are locked into a machine that pulls on them with more and more pressure until they snap. The carabiners need to take at least 4,900 pounds of pressure without breaking. This one held on until 6,000 pounds. If the samples pass the snap test, every carabiner in the batch goes one by one into a machine that simulates the weight of a 250-pound person hanging on a rope. Once in the machine, a robotic arm opens and closes the gate to be sure it functions while supporting the weight. If the carabiner can take all that, you know it's ready to lock, load, and carry you to the top.